Hi everyone. So naturally, if you're already familiar with the mean value theorem or Rolle's theorem, please feel free to just go on to the next screens because that's basically what I'll be talking about. So the mean value theorem basically requires two conditions to be verified. One, f of x must be continuous on a comma b inclusive, and two, f of x must be differentiable on, which basically means that you should be able to take the derivative of it between a and b. If these conditions are true, then at least one c on a comma b exclusive exists such that f prime of c is equal to the average rate of change, or is equal to this equation. However, I want you to note that c cannot equal a or b, or else there's no applicable c. And the reason this is true is because looking at my example, if this theorem produces a c such that c is equal to a or c equals to b, then you might notice that there's no limit from the left for a, and there's no limit from the right for b. And therefore a and b don't have limits, and therefore the derivative is not defined, and therefore f prime of c is not exactly a relevant point. So Rolle's theorem is basically a special case of the mean value theorem. It uses these two rather familiar conditions and adds a third such that f of a must equal f of b. And it says that if these conditions are satisfied, then some number c exists in a to b exclusive such that f prime of c is equal to 0. And the same warning also applies. Now, this is intuitively true. If it's differentiable, then it can't go off to infinity. There must be no vertical asymptote, and it can't be a straight line, because that would also not have a defined derivative. And therefore, it must go up and then it must go up or down, and then go back to b. Consequently, there must be a max and or a min between a and b, and so there must be a location where c exists, such that f prime of c is equal to 0. So what you should have basically gotten from this lesson is the mean value theorem, and the special case of Rolle's theorem. All you really have to remember is that these two first conditions apply for the mean value theorem, or the average value theorem, and the third condition, that is Rolle's theorem. The only result that you have to remember is that f prime of c is equal to the average rate of change, because if you look at the special case for Rolle's theorem, you can derive the result for Rolle's theorem by realizing that if f of a is equal to f of b, then the numerator here is equal to 0, and therefore f prime of c is equal to 0. So really, all you have to remember is the mean value theorem's conditions and Rolle's theorem's conditions, but you only have to remember one result. Okay, so in my APBC calculus class, we had to show basically two things for work. One, we have to show that we actually recognize what the conditions were, and we have to show that we checked the conditions, even if all we really wrote was that f of x is continuous on a to b inclusive, and therefore mean value theorem works, as long as it's also differentiable between a and b exclusive. And two, we had to show that the derivative is continuous. So an example of this is if I realize that the f prime of x is equal to x squared, it's therefore differentiable on all a to b exclusive, and therefore it's always continuous, and therefore it's continuous on the interval I'm interested in. So having shown these things, that's really all I have to do for work in the class that I participated in. So thank you guys. I hope this was informational, and have a nice day in calculus.